Welcome back. It's time to talk about tables! Periodic table. So a little bit about this video. I'm going to give you a glimpse into the periodic table. You'll learn some more in class and then go even further with Coach Strong's next video. So a little about the periodic table. It organizes all our known elements into this unique situation we call the periodic table. It's created by Dmitri Mendeleev in 1869, and the moment he published his article with this periodic table, there were only 63 known elements, and as of today, we have 115, so we're adding stuff as we go. And it's arranged using groups, periods, based on characteristics. So let's start by talking about the periods. The periods are rows. They go from right to left, so this would be a period. There's a total of 7 periods, and you know this because on the left of your periodic table, it's got the numbers 1 through 7. So this is period 1, 2, 3, 4, 5, 6, and 7. A nifty, helpful thing that the periods do for us is they show us how many orbitals there are in an element. And an orbital is the same thing as a shell, rings, or energy levels. So let me give you a basic introduction to an orbital. So in the center of your atom, you have your nucleus, where you find your positive protons and your neutrons with no charge. And then you have your electron cloud on the outside of that, where you find your electrons. Sometimes we diagram this using rings, shells, orbitals, okay? So if lithium, which is right here, is in period 2, all that means is it's going to have 2 orbitals around the nucleus. So if something is in period 6, it would have 6 rings. If it's in period 4, it would have 4. That's all you need to know at the moment. Now let's move on to groups. Groups are our columns. They go up and down. So here's a group, here's a group, here's a group. Groups are also called families because just like a real family, they share certain characteristics. So if something's in the same group, it's going to have the same chemical or physical properties, and it's going to have the same number of valence electrons. Groups have numbers also, just like our periods do, and here's where you find your group numbers. At the top, guys. Okay, so you don't need to worry about these that I'm Xing out. Don't worry about those. Just look at these numbers right here. So group 1, group 2, group 3, 4, 5, 6, 7, and 8. You may have recalled that I just said a word called valence electrons, and maybe you were scratching your head. Valence electrons are just like regular electrons, except that they're found in the outer shell or outer energy level of an atom. So let's do a quick basic introduction to valence electrons, and remember, you'll get more in a moment. So let's go back and talk about lithium. I'll outline it. So here's lithium again. We know that lithium has a nucleus, and in that nucleus you'll find positive protons and neutrons with no charge. And you'll have your electrons. Well, we found out when we talked about periods that since it's in period 2, it should have, that's right, 2 orbitals. So we'll draw 2 orbitals around the nucleus. And because of 8-man, you know that since the atomic number of lithium is 3, that it also has 3 electrons and 3 protons. So I'm going to draw my electrons. Here's 1 electron, 2 electrons, and 3 electrons. And this guy right here, who's on the very outside ring, he is a valence electron. You know how many valence electrons there are in each element because of its group number. So since lithium's in group 1, it has 1 valence electron. Since boron right here is in group 3, it has 3 valence electrons. So here's some more. On this example, if it's green, that means the element is solid. If it's blue, it's a liquid. And if it's yellow, it's a gas. Everything that's beside this line is what's called a metalloid. Left is metals, right is nonmetals, middle